Good morning, ladies and gentlemen. It's really a pleasure to welcome you on behalf of STOWA and the Watermozaïek on this very special day. My name is Verhoeven, and you can recognize me because I'm the only one with a tie today, so that's very easy. I will guide you through this series of lectures. It's a special symposium, I can say, because for several reasons. The first reason is that we have a nice consortium of scientists trying to convey their messages they found in their research to an audience mostly of people from practice, water managers. And we have 2 days. The first day is international, where we have speakers from other parts of Europe mostly and the Netherlands telling stories. And the second day is more local. So I think in the first day we will have more global and maybe European issues. The second day issues especially important for the Netherlands. The other reason why it's so special today is that we are meeting in a zoo. And it's also a very nice one. If you have not seen it yet, you should take a chance today to walk around. We have very nice animals, including the hippo, which is of course a very important animal for all of us, and some people have been inspired by it to write poems. And maybe a zoo is also an area where you can still appreciate how diverse nature actually still is. But on the other hand, maybe it's also a little bit ominous that we have to make sure that not all life is ending up in zoos around the world. Let's make sure that that doesn't happen, and I think we are in a position to still prevent that, but we have to work hard. Of course, introducing a day like this cannot be done without showing some pictures from the IPCC, which is a very, very respected organization without any flaws, right? So, still, if you go to the IPCC's website, you will definitely be very impressed by the amount of information that is there and by the way in which their reports are really loaded with data and graphics. So you can only be impressed, actually, if you see what the IPCC is doing and has done. And, well, this picture, of course, is known. You all know that CO2 is rising and that the models of the IPCC are predicting that the temperature will increase globally. And you see that both the predictions of CO2 rise and the predictions of temperature rise do have quite a range. They are not really a thin line, but they are a whole collection of lines, depending on the scenarios, depending on different kinds of models that are being used. The mean temperature increase, you see again this in a picture where you see the average values. It's definitely true that it's going to increase, even if you assume that we are going to stop emitting greenhouse gases. Then we will end up with this line here. And it's very probable that we will not stop emitting greenhouse gases. So one of these other lines will probably be the future. And you see that this particular picture stretches it all the way to 2300. Seems a long way from here. But then the increase is in any scenario in the order of between 2 and 4 degrees. And it could be more. What that means for the world, this is only an average value. You can see here you have 3 time periods, and you have also 3 different models and scenarios. But the common picture is that the temperature increase will be more severe in the north and near the poles, and less dramatic near the equator. And you see that in the course of the coming century, the increase is going to be quite dramatic, especially in the areas where the increase is the highest, where the vulnerability is also the highest. The same you can see for sea ice. Here we have a graph which already includes the current situation and the last century, where you see that sea ice in the northern hemisphere and in the southern hemisphere is already declining. And where you can see that depending on the models that you use, the decline will be even go further. And we all know pictures of the ice sheet in the North Pole, how it has already decreased, how we can almost have a free through route with ships from in the north of Canada. And that's not all. We also have changes in precipitation. This is showing globally what will happen with precipitation at the end of this century, and it's in millimeters per day. And again you see that there are areas that will become drier and also areas that will become wetter. Also the precipitation intensity is going to change. It's not only the amount that we get, but it's also the showers will be more intensive and will be more dramatic. And also in the, on the other side, the dry days will be also more intensively dry and longer. So these are all predictions that we are already kind of familiar of because we read them in the newspaper, but if you see them in a row, it's still impressive. And then we have, of course, the sea level rise, and this is the most conservative estimate that the IPCC has come up with, where they have not taken into account any loss of ice on Greenland. And already we know from recent research that the ice in Greenland is moving too, is melting, and the sea level rise that is indicated here is probably just an underestimate. Maybe a problem that you are not so well aware of, and that has only been recognized maybe a little bit more than 5 years ago, broadly in science, is that because of elevated CO2, the pH of the oceans is going to drop. So the oceans become more acidic. And the effects of that will be that there will be many animals that will have problems producing shark skeletons, including coral reefs. And already there are measurements that have already demonstrated this acidification. And if these predictions will become true, the marine life will have a problem. There is also, apart from the pictures that I just showed, which are from the assessment report 4, published in 2007, there is also a special report on climate change and water, which was published in 2008, and where we also can find some more information on freshwater. So this is not only giving you the precipitation in millimeters in percentage, increase and decrease, but also what it means for soil moisture, for runoff, and also a graph for evaporation. You can see that the differences in precipitation also lead to a totally different hydrology of ecosystems worldwide. So if these changes happen in climate, we will also have a very important change in hydrology, which is especially important for aquatic systems and wetlands. If we are not talking about freshwater related impacts, this is just a selection of problems that are being predicted for the next 50 years already. Droughts in the central part of the United States, where we have not enough water to produce drinking water anymore, by even after 2020. We have here in Brazil a shortage of groundwater recharge, also leading to drier conditions. We have a problem in Spain with electricity production, less hydropower. Also in Spain, we have lower wheat yields because the groundwater is just retracting and there's not enough water to grow all these crops. We have increased pathogen load due to more heavy precipitation in these areas. We have in islands all across the ocean that the layer of freshwater is becoming thinner because of sea level rise, and we have also problems of flooding. Here is indicated for Bangladesh, but we could also think of this little area here. And this is a graph showing for Europe the most important biomes that we have, ecosystem types. And you see that in the tundra we have some thawing, increased erosion also in this area. We have, importantly, waterlogging, eutrophication of lakes and wetlands, very important for what we are talking about today and tomorrow. More erosion and reduced ski season. I don't know if that's a problem, not for me, but for other people it will be. And then we have the Atlantic region, more coastal erosion, more people on the beach, and also greater winter storm risk, with much more river floodings. And then we have Central Europe. We have already seen that with all these strong winter floods. The mountain areas, the glaciers are disappearing. You all know that. If you go to the mountains, you can see it. And then in the Mediterranean, we have this very long enumeration of problems, reduced water availability, drought, etc. And then we have finally here the steppes, where also inland it is expected that drought problems will also be eminent. So we are really interested as aquatic ecologists, not so much in the global perspective, but what does it mean for ecosystems? How will ecosystems be modified by all this climate change? And in the Millennium Ecosystem Assessment, it has been already recognized that the freshwater ecosystem biodiversity is probably the most sensitive for climate change. So we really have to especially worry about that and study what the effects could be. They're often non-linear. We have a shift in stable states that are not so easy to predict. So if you really try to evaluate impacts on ecosystems, it is difficult because ecosystems are very complex systems. To predict how they will react is not an easy task. Some things have already been listed as trends that are already going on. Increased stratification in deep lakes, taking away more nutrients from the surface layer because there is a longer period of growth. In shallow lakes we have more anoxia and algal blooms, which create many problems that were just in the stage of being solved. We had better water quality, but now climate change is going to spoil everything. Flooding and drought will be more frequent, and we have invasive species. Climatic impacts on freshwater wetlands. They are most drastic in inland, continental areas. Droughts and excessive rains will increase the variability. And, well, you see that for wetlands it's very important what water sources are important. So it's always a mixture of groundwater, surface water, and rain. And the proportion of these three sources is going to change. And that will dramatically impact the functioning of these systems because they are very much fine-tuned on the water that they normally get. Well, wetlands are very diverse, not only amphibians and reptiles, but you can also think of birds. And, well, they are vulnerable in that respect. If you have many species, you can lose them. And, well, the most vulnerable ones are bogs, depressional wetlands, vernal pools, and monsoonal wetlands. This picture I was a little bit shocked about because this is a picture that was presented in 2009 in December in Copenhagen. And it shows some outcomes of the fourth assessment report, and it shows the number of studies that indicate that warming is actually taking place. And you can see these boxes give a physical and a biological data sets. So, and it gives you the number of studies that have been done. So for the terrestrial environment, we have 764 studies on physical characteristics, and 94% of them are indicating climate change. They are consistent with the climate change idea. And biological studies have been done 28,586. That's for the terrestrial environment. Now for the marine and freshwater ecosystems, the number of studies done is 1. That cannot be true, right? and the number of studies on biology is 85. That's shocking, I think, that it shows that either this guy of the IPCC is a terrestrial ecologist, or maybe something else is going on. I also saw the date, and it's true, of course, that Olympics only started in 2004. So it could also be that the project was still starting up, and that we will now see more in the future. So now we are coming to the symposium of today. The idea for this symposium actually is from Bas van der Wal of STOWA. He visited the last Olympics workshop in Blanes in Spain, and he was very enthusiastic. And when he came back, he said, why don't we hear these stories in Holland? I think the water managers in Holland should hear these presentations, should have this information. So before we knew, we were around the table and making a plan. And Olympics is a large project. It's finished last year on evaluation of global change impacts on freshwater ecosystems, focusing on lakes, streams and wetlands. It was actually the amalgamation of 3 different projects that were happening before separately on lakes, streams and wetlands, and they were all put together in a big hall and had to sort out a common plan. The good news is also that there is a follow-up for Olympics that will start very soon, and will work with part of this very large consortium that Olympics was. So let me now introduce the program of today. We will start with Erik Jeppesen from Denmark, who is a very well-known lake ecologist, aquatic ecologist, worked all around the world. Lake ecosystems is his topic, with special reference to fish communities. I'm sure there will be much more on in his talk. Martin Scheffer from our own country. He is not in Olympics, but still we have invited him. He is, of course, the aquatic ecologist that we are the most proud of after the awards he has gotten and after all the good work he has done. So we are very happy that he is here. Shallow lake systems, trophic interactions, and of course his specialty, stable states. Brian Moss, the poet. Thank you very much for being here. Very inspiring during the Olympics project always, and a long history, because when I was a PhD student I was already reading the publications of Brian Moss. So that shows you how long he has been around. And then for the morning program, finally, Marcel Klaassen, who is now himself a migrant because he just moved to Australia, but he is very specialist on migration, so he is definitely knowing what he's doing. Migration routes of waterfowl and consequences for aquatic ecosystems.